And we're live. Okay, welcome back to the future of. I'm your host, Jonathon Narvey, and I am very happy to have our next guest with us, Eric Daimler. And so we're going to be talking about the future of AI and the data pandemic. And Eric is the perfect person to talk about this. I'm going to just give a brief synopsis and then let Eric fill you in on exactly why he is the exact person who should be talking about these things. Number one, Eric is the CEO and co-founder of Connexus.com. He's an investor, he's a policy advisor, a keynote speaker, he's author of The Future is Formal, How the Best and Worst of AI is Yet to Come. If I'm not mistaken, you're also a former member of the Obama administration. You come with quite the resume, Eric. So maybe you can talk a little bit more about your background and what makes you the expert in this space.
Well, it's good to be here. Thanks for having me. It's terrific to be speaking to the audience and about this important issue, which is getting people involved in the discussion around the future of, we'll say, information technology. For me, I'm just really grateful that I, for a lot of reasons, have spent 20 plus years in different aspects of artificial intelligence and automation, from being an academic researcher to being a venture capitalist on Sand Hill Road, to being an entrepreneur. And of course, people often know me from having spent time in the Obama White House as an authority on AI during the last year of its administration. So I've seen it from a lot of different angles. I may be unique, if not rare, in that, or at least rare in that combination of experiences around this technology.
Well, this is fantastic. And I recently came across an article of yours, The Data Pandemic, How the COVID-19 Crisis Exposed a Critical Weakness in the Nation's Data Handling. And I thought this was, it was such a great sort of nexus of a number of the issues that you like to talk about, but obviously in the context of something that's very timely on everyone's minds, the hopefully soon to be ending COVID pandemic. But let's first, before we get into what you go into depth in the article, let's lay down some definitions. So you talk often about the issues of data integration, the data deluge. What are we talking about? What is the problem that we're seeing with IT systems integration data that everyone should know a bit more about?
Yeah, thanks for that. It's a good place to set out some nomenclature. When people talk about artificial intelligence, I still see people going in and out of how they define it. The traditional way of looking at it is as a set of algorithms. It's in computer code. And if you wanted to get more specific, you could say that machine learning, which is a term that you'd often hear about, is actually a subset of artificial intelligence. So machine learning is a subset of artificial intelligence. Deep learning, also something that you'll read about in the popular press, is a subset of machine learning. That level of specificity, however, isn't terribly useful to the 99% of people or more or fewer that are not researchers. To be hyper pedantic and talk about non-machine learning artificial intelligence is true, but not necessarily helpful. What I find to be more helpful to have people engage in the thinking around the implementations around putting AI in the real world is to think about AI as a system, as the total system that includes those learning algorithms. So we can think of sensing, collecting data, and the collecting data could be coming from anywhere. It could be coming from the laser detector on the top of my car for automatic cruise control. It could be coming from the air sensor that I have in my house to detect air quality. Those are sensors. Those are collecting data. After the data is collected, that's sense. The data it goes through a network and all the infrastructure of telecommunications to the processor to think, to plan. That's often where traditional AI rests. That is an important thing to think about, but it's just really one part before the outcome then it turns into action, what actually happens. So in a real world scenario, we might have an automated car coming up on a crosswalk, collecting data around the world and determining if what it sees in front of it is a crosswalk or is it a shadow? Is the additional object a person, or is that a shadow or some unusual array of light? Then that goes into through the network into computation, traditional AI, planning. But that action needs to be determined. That may be separate, actually, from the sensing, certainly, from the network, certainly, from the planning. That's separate. So what happens? What degree of confidence did humans put into the system to tell the car, should it slow down? Should it change lanes? Should it come to a complete stop because the consequence of error is so great? That's an action. And then that whole system then learns from its experience. Sense, plan, act, learn from its experience. That's what I think is the more useful definition of AI for your listeners, for those consuming this conversation. Sense, plan, and act, and learn from experience. When you have that whole system, that gives you a place to grab onto in thinking, where can I get involved, even if I don't work as a computer programmer in my day-to-day job? What do I care about? Well, I certainly care about cars stopping at crosswalks. So that gives me a place to have a conversation with the computer programmers that are encoding this automated system into our daily lives. Sense, plan, and act.
So this is a great sort of theoretical basis for the ensuing conversation. I want to get into well, that was a very practical example, but also I want to get into the timely newsy aspect of the article that you wrote. So I'm gonna quote you, so maybe you can talk about, again, how data integration and integration of IT systems, perhaps AI, are, how these things may be rolling out a little bit less effectively than we'd like. So I'll just begin. Data collection and handling both, sorry, I should actually back up a bit. While the COVID-19 pandemic itself may be unprecedented, America's poor national response to it shares some of the same root causes as previous public health care failures, including the disappointing initial rollout of the Affordable Care Act. Both cases involve the need for massive amounts of heterogeneous data to be shared by many IT systems. In the case of the novel coronavirus, reliable data was needed to track COVID-19 prevalence, among other factors. And so in the cases we saw, the initial data's quality and handling were largely ignored, leading to critical problems later on. Can you break that down for us? Where is the system breaking down in terms of data integration, and what are the solutions that you see to this?
Sure. So what I discovered in working with artificial intelligence in the Obama administration in the White House was that a lot of energy was spent on the learning algorithms themselves. In some cases, justifiably so, because in the case of the protein folding coming out of DeepMind, that's magical, and the implications are large. But we need not overly uh, exaggerate the applications of that technology to every other part of our lives. That required a massive amount of data in a particular structure in order to solve the problem. And deep learning, that is used by DeepMind, is really well suited to that particular problem with that particular data set. For much of the rest of us, we have different sort of problems, I came to realize. And that problem is bringing the data to bear, just finding the right data and then integrating it, just making it one cohesive whole. So you can imagine in your daily life, you've used Microsoft Excel or some similar worksheet, Google Sheets or something. And in those spreadsheets, you can work with a few dozen, maybe a few hundred, maybe a few thousand columns. If you then started to work with different sort of worksheets and you said, well, I'd really love to do some analysis across these multiple Excel files, then that become a little more complicated. If you then multiply that by the rate of data growth we have today, where it becomes millions of Excel spreadsheets, or really at the rate of growth, maybe billions or even trillions of these spreadsheets, it really becomes meaningless to talk about any one particular spreadsheet. You're going to have to talk about it at a completely different level. And bringing all those together into one cohesive whole upon which to do analysis then becomes itself an abstraction and a job.
Right.
This is increasingly the impairment behind almost every business problem and almost every public policy issue.
Right. So just sort of closing the loop on the question and your answer, which you've laid out the context specifically to do with dealing with whether it's this pandemic or we know there's going to be future pandemics. There's going to be future national crises. Where do you see this integration of different data sets into a single cohesive system? From a practical standpoint, what solutions get you excited, and where do you see maybe danger ahead?
There are a lot of companies that are beginning to recognize that they are falling behind relative to data growth. We're working with a very large Swiss financial services company, which for 7 years has found and struggled and failed to bring their information technology infrastructure up to the level it needs to be to fulfill on their business goals. They cannot write contracts, really, and interpret contracts fast enough to fulfill on their business growth ambitions. So that's actually the problem. How this manifests itself in things like the COVID-19 vaccine response and the COVID-19 vaccine distribution is in these really strange ways in which humans will tend to interpret data differently. So an example is we worked with a very large medical supplier, hospital system in the United States that quite literally had across its own system, not even different hospitals, different interpretations for diabetes. And you might say, well, that sounds really weird. These are physicians, they can say diabetes. The issue is if you put it, again going back to your Excel file, spreadsheet, whatever, you say a patient has diabetes. One group, for their purposely good reasons, might say diabetes, yes or no. Another might say, well, diabetes, how much, how badly, what are the measurements? Another might say, well, diabetes, how are we treating it? Those are different ways, we'll say, of treating diabetes. You can't just bring those all together into one column that says diabetes. And if you had those in 3 columns, then that's a different type of data that needs to be analyzed. I'm giving you the very fine details of how this data gets messed up, and when this gets multiplied across not just one hospital system, but multiple hospital systems across a whole province or a whole country, let alone the whole globe, and then you map onto that privacy concerns, you have an increasing problem. I've come to believe that the only solution to this is more fundamental than computer science. It's actually in a level of mathematics. There is a branch of mathematics, and I know this mathematics can freak people out and give people flashbacks to high school. But the mathematics is more fundamental than computer science, and that's where this problem needs to get solved. There's a branch of mathematics called categorical math, category theory, and that categorical math is really the place at which this problem gets solved. And it gets solved through creating some formal rules, we'll say, a formal way of designating how you interact with data. I could say more about that, but that's the problem and that's the solution.
Sure, sure. Well, that I think that covers that adequately. I actually also want to delve into more of a big picture around growth of AI and well, our technological society and increasing interconnectedness, increasing convenience. These are all good things that come with the technological advances we've seen, including AI. I'm not sure if you covered this in the article or if I captured this elsewhere, but it seemed like you generally see AI and machine learning as a is it fair to say you're a booster of it in the sense of warnings over automation effectively killing jobs are as we've seen in the past, technology tends to create more jobs than it destroys. Is that a fair assessment of what you've said?
I think there are arguments to be had around jobs that about whether it creates more jobs than it destroys or whether it's neutral. I think that you and I, just sitting here having this conversation, enjoy a better life, we'll say, certainly better lifestyle than our grandparents or our great grandparents who will have tended to have worked on a farm or in a manufacturing facility because of increases in productivity. That's what generally has lifted humanity out of poverty, generally what has increased the life expectancy and the lifestyle of all of us living in Western society. So increases in productivity. Increases in productivity can come rapidly through these digital technologies, including artificial intelligence. What's different, what's changed, is not job losses or job disruption. What's changed and what is really worth addressing in some really serious way as a conversation in society, in civil society, is the abruptness with which these jobs change. Once a digital technology works, that change is rapid. So we no longer have a generation that can live out their life as an elevator operator and then retire, or a switchboard operator and then retire, or a typist. Remember, we have those. Some of those jobs have gone away without anybody shedding a tear. Bond traders might be one of them. Stock market floor traders might be another. Those don't really exist anymore. The floor of the New York Stock Exchange is mostly a tourist attraction now. It's not really any longer for trading stocks, but nobody really cries about the loss of those jobs. What changes is once the digital technologies have worked, those jobs go very, very quickly. And that can be terribly disruptive. And I think as a society, we would benefit by acknowledging that disruption and finding ways that are appropriate for us to address it. But the improvement to our lives from automation is really difficult to underestimate. We experience it right now by being able to survive, many of us, during this lockdown during COVID. Automation has served to keep much of our economy working, and there's a lot of lives to be saved from deployment of automation. We see this in our cars right now. This isn't artificial intelligence in the way that many people think about it, but there's certainly automation technologies in traction control, automatic braking systems, in automatic cruise control that's guided by radar. We benefit from these technologies in many, many ways. And so I want people to engage in the conversation about how to embrace these technologies when appropriate and how to measure their deployment when appropriate.
If you were in charge, okay, let's say you're back in, you're not in the Obama administration, that's history, but you're in the Biden administration, and you are either in something akin to your previous role as advisor on AI, and maybe add in the automation aspect of it. What would you see as number one? Is there anything government can do or should be doing, or should they just be getting out of the way of ensuring that these changes, obviously the huge benefits that come from automation, but you have noted there are some areas where we need to proceed maybe with more care, with more thought. If you were part of the current administration, if you were president, what would you want to see happening on the ground? And I get that this is a fairly broad question, so answer it as you like. But in terms of AI, automation, the changes that you see happening, maybe what do you see as what would be maybe some good policies, or again, maybe they just stay out of it? What would your answer be?
Yeah, I will take that last part first about government being involved or not being involved. I don't think this is one of those right-left arguments about regulation or non-regulation. I think really there's different arguments to be made. And I actually wrote a different article about this, an open letter to the president about what I might suggest were I to be in this in that role again. I'm happy to say that President Biden has elevated the group with which I work into a cabinet level job. It's officially a science advisory group to the president, characteristically, I guess, of him. So it has even more visibility in the Biden administration than the ample visibility it had during the Obama administration. And that my guidance really applies to Canada, on all Western governments, as much as it applies to the United States. I might take among my recommendations this one first. You need not be a computer programmer to be involved with technology. That there are many, many ways in which to be engaged in the automation technology society, the technology infrastructure of a company without being a computer programmer. I work in a particularly interesting field of technology, and I have found that Amazon is opening new jobs in this field called ontology. So it's not ontology in the philosophical sense of the nature of being. It's actually ontology in the definition of terms, formal definition of a lexicon. This has huge implications in life sciences, and that's traditionally where you'll find these jobs. But this is now getting to be a need at an Amazon. It is necessary because Amazon is becoming so large and has acquired so much knowledge that it actually needs to hire a team of people just to formalize the capturing of that knowledge. It's really crazy. And so as other jobs you might say are automated away, their warehouses employ fewer people than they might have needed 50 years ago. That's why it works. They now have 12, as far as we've been able to count, 12 ontologists, and they have 12 more job openings for ontologists in 2021. Those numbers sound small, but it's at a job that really didn't exist 5 years ago. And other companies are also hiring for ontologists. This gets to my point that these people aren't computer programmers, but they're working in a very sophisticated part of our employment infrastructure. This is going to be a global need, and it's going to be an increasing need. And it's an example about how people can find their own place outside of just the nerdy existence that really defined my upbringing.
Absolutely. Well, that's terrific. And I know we haven't met before, but I am, of course, a big booster of technology. I'm not a technologist, a maker of technology myself, but I like to be in this circle. So I often work with people who are on the frontiers of technology. So it has been, again, a wonderful conversation talking with you about AI and data integration. And before I let you go, you've been very generous with your time, Eric. I was wondering if, maybe a quick plug for Connexus. Maybe you could talk just briefly about what you're excited about that you're developing there.
So what we are about is data integration. So we'll say upstream from AI. We have a lot of very large clients, companies you would have heard of in a range of field, from logistics to life sciences, that have very, very large data concerns that need to be brought together in order to be doing better predictive analytics, to be doing their AI. When you're thinking of complicated data sets with generally legacy databases, that's where our company gets to be called. We are, to have MIT call it, in the existence of MIT, we are the first spin out ever from their math department. Trivia, fun fact.
Interesting. Yeah. Okay, so if my audience wanted to learn a bit more about Connexus and actually yourself, your own profile, how would they find you?
I am Eric Daimler at LinkedIn. Connexus.com obviously is a good place to go, and then Twitter, I'm EAD, my initials, and Facebook, I think I'm Eric Daimler. Instagram, Eric Daimler. Any other usual place.
That's terrific. I've noticed you're a very prolific guy, Eric. So you're on all these platforms, and you're also CEO. And you, again, the extensive resume. I don't know where you find the time, but I really appreciate your time. Thanks for coming on The Future of. Today we've been talking about the future of AI and the data pandemic. Thank you very much, Eric. It's been a real pleasure talking with you. And to my audience, I will see you in the future.